right? That could work there. Nice. So we looked at this expansion here. Let's just try one quickly, and then we want to take a look at Maclaurin's, right? Right. Gonna get back an example here first. I'll do a past paper just now, right? Let's say quickly, I want you to expand the 1 minus x to the minus 1. Right? Let's say we could get up to x cubed. So let's expand up to x cubed. Right, so just expand right until x cubed, right? Right, so the first value is 1, then n is minus 1, and x is minus x. Yeah? Don't forget that, yeah? X is minus x. Go ahead. To the next two there. So the next one is what? N minus 1, minus 1, minus 1, all over 2 factorial by minus 1 squared. And the last term will be minus 1, minus 1, minus 1, minus 1, minus 2, all over 3 factorial by minus 1 cubed, plus dot, dot, dot. So here is 1 plus x. So that'll be what on top there? That'll be minus 2 by minus 1. So that's positive 2 over 2 factorial, which is 2, x squared. On top there is what now? That's minus 3 by minus 2. That's positive 6. So that's minus 6 over 6. 3 factorial is 6. Minus x cubed. So I got 1 plus x squared plus x cubed. Anybody got that? Yeah? Anybody online got that? Okay, nice. Yeah. Okay, so what will happen if I ask something like this instead? Suppose I asked, suppose I wanted you to estimate, suppose I wanted to estimate 1 over 0.99. What you'll do? Suppose I wanted to estimate a value for 1 over 0.99. What can we do? Of course, we need to use what is a hence, right? So hence estimate 1 over 0.99. Any ideas? Right? Reset to use x as 0.01. That makes sense, right? Right? Because what you see here, 1 over 0.99 is 0.99 to the minus 1. That's okay? How do you get 0.99 if you have 1 minus x to the minus 1? Right? All we have to do is to let x equal to 0.01. That's okay? So if you let x equal to 0.01, you'll end up with 0.99 to the minus 1. Then you're coming back here in the expansion and you're substituting x is equal to 0.01. Right? So that'll be 1 plus 0.01 plus 0.01 squared plus 0.01 cubed. Take one message plan. Message apply. Huh? You're supposed to remember you have applied. Sorry, but I already applied, right? All right. And anyway, we will talk about the SBA answer. All okay with that? 1 plus 0.01 plus so on and so on and so on, right? Everybody okay with that? How much you got? You can just check it, madam. How much you got? Like 3 significant figures good. Three significant figures okay, right? Right? Aidan got 1.01. Anybody else got a 1.01? Nice. Let's do one more. This is a past paper, whole year, 2001 or something. Any questions there? Aliyah, any questions? Dylan? Kyra? All right, so try this one here for me. Expand the square root of 4 minus x up to up to x squared, right? And estimate for me the square root of 3. Estimate square root of 3. Estimate the square root of 3. right? I'm doing it like this so that you could use the if you want, you could use the expansion for 1 minus x that we had earlier. Right, so you'll get the square root of 4 by 1 minus a quarter x to the power of a half. So therefore, all you have to do really is expand 1 minus a quarter x to the power of a half. Just expand that out. And then multiply it by root 4 after. Right? Or you can start right here. 4 minus x to the half and go and do it from right here. Right? So it will be 4 So you could use the original binomial expansion and work it out. Just remember, square root of 4 is 2. Just remember, half C1 is simply a half. This is 4 to the negative a half by minus x plus a half C2 is what? A half C2 will be a half by a half minus 1 all over 2 factorial by 4 to the what? Minus 3 on 2 by x squared. And you're good to go. So this is 2 plus, sorry, I didn't give you time. Hurry up, finish it up. Come on, again. So you have 2 ways to do it, right? You could do it like this method here. You could do this method here or the next method, right? Right? You done right. So we'll got root 3, right? Let's see what you get for root 3. All right, so you should get 2 plus, sorry, that'll be minus, right? A half by a half is a quarter, so that'll be minus a quarter x. Right? Simplify it out and you'll get minus 1 on 64 x squared. Correct or no? The half minus a half all over 2, that's 116. Yeah, 164. All right, nice, by x squared. Right, how we get root 3 now? To get root 3, it will be 4 minus 1, right? 4 minus 1 to the power of a half. So therefore, we're going to let x be 1. You're going to let x be 1 and negative 2. So that'll be 2 minus a quarter by 1 minus 1 on 64 by 1 squared, which is how much is your significant figures? How much you got it? $1.73. Nice, 1.73. Nicely. Okay. One of the things that we had to point out, because there's access sometimes, right? In this expansion here, right? This expansion is valid for the modulus of x being less than 1. So let's make a note of that, right? Sometimes they will ask, when will this expansion be valid? Right, so it's valid when the modulus of x is less than 1. So for example here, when is this expansion valid? So right here, expansion is valid, right? Expansion is valid when the modulus of 1/4 x is less than 1, right? If you multiply both sides by 4, you could basically say mod x is less than 4. So sometimes they'll ask you that. When is the expansion valid, right? Okay, that's something I wanted to point out here. All right, when we were doing the binomial expansion, right? I gave you this long expansion here. A to the n plus nc1, a to the n minus 1, b to the 1, plus nc2, a to the n minus 2, b squared, dot, 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 until we reach it, until we reached ncn by 8 to the power of n, right? Until we reach all the way down there. Nice. Sometimes we don't have to do the entire expansion. We could just find something called the general term. So instead of expanding all you want the third term, all you have to do is use this general expansion here. NCR by a to the n minus r, b to the r. And this gives the r plus 1, 2. Right? I want to show you how to use this, right? So this is a general form here. It helps you in the expansion. So you don't always have to go and do all the entire thing, right? Copy it down. Shivani, you okay? Yeah. All right, nice. So let's take a look here, right? Let's say, for example, I would like you to find, I don't want you to expand it out, right? I would like you to find the coefficients of x cubed coefficients of x cubed in the expansion 2 plus x to the power 7. So I don't want you to go and expand the whole thing out. Okay, let's see how we're doing this, right? So we know what A is, we know what B is, and we know what N is. But we don't know what R is. We have to figure out now which term is going to help us get that x cubed term, right? So watch this here. So we know N is 7. So 7 CR by A is 2 to the 7 minus R. By B is what again? X by X to the R, right? So we need this. We need to obtain coefficients. We need to obtain coefficients of x cubed. So if you look at Dale, what value R has to be here to get x cubed? What value R has to be there? What value R has to be? 3, yeah, 3. This one was easy. You just had to plug in the value right in, right? So by putting R is 3, you're good to go. So you really and truly is 7 C3 2 to the 7 minus 3 by x cubed. And you get to, could you work out the coefficients? What is 7C3 by 2 to the 4? That's the coefficients, right? What is 7C3 by that? $560, thank you. 560. Right? 560. Right? Copy down. Sometimes it's be a little more challenging, like the one I'm going to give you here. Right? Yeah, change it. Right, so let's see if we could find the coefficients of x squared in the expansion of x plus 1 on x to the power of 6. Right, so again, we know what's A, we know what's B, and we know what's N. Right, we know those 3 things, right? But again, we don't know what's R, because we want to get x squared, right? So we know that NCR, which is 6CR, is equal to x to the 6 minus R by 1 on x to the R. This one a little bit harder to figure out what value will work, so we'll simplify it a little bit further. This will be 6CR x to the 6 minus R, 1 to the power R is 1, x to the power R. So we're going to simplify the x's. We're going to simplify the x's. So it's x to the 6 minus R over x to the R, which is the same as 6CR by x to the 6 minus, remember you divide in same base, right? So 6 minus R, which is the same as 6CR by x to the 6 minus 2R, right? Here we have to figure out now. We would like this value here to be equal to 2. So what does R have to be? What does R have to be for that to be 2? Good job, done. Brian, what does R have to be there for it to be equal to 2? What value R have to be? Just look at this. Solve that fast. Let's solve for R there. Three, you sure? 2. Carry across the 2R, carry across the 2. 2R is 4, so R is 2. And that's it. You got to go. 6C2 is equal to x to the 6 minus 4. So 6C2 x squared. So therefore the coefficients is what? What's the coefficient of 6C2? times. So the coefficients is 15. See that? You know, see now? 6 minus 2R is 2. Carry this here, carry this here. Huh? What is? Or in the calculator, put 6C2 in the calculator. NCR, put 6 NCR2. Put 6 NCR2 in the calculator and you should get 15. Right? Here's what you're doing for me now. Same question. Same question, but here's what I want. I would like to get the term. That was part 1 here, right? Same question, part 2. Find the term independent of x. What does that mean? What does that mean? What do you think independent of x mean? Divya, what do you think independent of x mean? X to the power of what? Independent of x means it has no x, right? So it's x to the power of 0. So if I said independent of x, you have to figure out which value will give you, which R value will give you x to the power of 0. What's the answer? R is what? So 6 minus 2R is 0. So R is how much? Nice. Correct. 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 Good. R is 3. Right? R is 3. So you're just going to find 6C3 x to the 6 minus that. So the answer is 6C3, which is 15 again? Oh no. 60 or something. 45, I think. was 63. $20 alone? $63 is 20. Yeah, correct. Last one. Last one on binomial, right? I'm finished with binomial. Any questions online there, Chelsea? Jason, any questions? Victoria, any questions there? None? All right. Let's do one more. This is 29. This is 2018. Just do one for man, then we'll start Taylor and Maclaurin's, right? X to the power 7, right? In x squared minus 3 on x to the power of 8. Do that fast? Deal. One question, deal. Right, do this fast, message answer.
Yeah, I'm not, it depends on age and it will be the amount of yeah, okay. So let's hold on. My name is right after.
On a Friday. Okay. Right, I have one value here. Any more, Kyra? Any more values there? Nadeem, any values? Right, so the binomial expansion is used to expand functions like this. But there are functions like e of x and ln and thing that binomial wouldn't allow it to expand. That's where Taylor is coming and Maclaurin is coming. All I got you? Papa, you can again have value. Actually, just plug in the and the formula next one. That's x squared, right? We have b and this is where is in two? We try this one here from a. Any more values? Right, you have your A, you have your B. Remember your B is minus 3 on x, and you have your N. Right, so you have 8CR by x squared to the 8 minus R by minus 3 on x to the R. So when you simplify this, you'll get 8CR by x to the 16 minus 2R minus 3R x to the R. Right? All you want to do now is bring the R's together. So you can simplify it like this, right? This will be 8CR by, I just working with the x alone, right? Minus 3 to the R. And then because they're divided, it will be x to the 16 minus 2R minus R. Okay? So that means 8CR by minus 3 x to the 16 minus 3R. Now, as we did before, we would like this value to be equal to 7. Right? How much is that? I got R to be 3. Anybody else got that? R to be 3. Yeah. So therefore, when R is 3, you'll get 8C3 by minus 3 to the 3 x to the 16 minus 3 by 3. Right? So this is what? Minus 27, right? By x to the 7. Was 8C3 by minus 27. All right, thanks, Aidan. 1512. Nadeem, you there? Okay. You got that, Nadeem? Okay with that? You didn't get it? We follow what to do. So to bring the x's together and simplify, right? All right, Nadeem. Thanks for messaging, Nadeem. So then check in to make sure everybody alive every now and again. Yeah, Nicholas, you alive there? All right, nice. That's good. All right, so that's your back. That is your binomial expansion then. The next thing that we have to be able to do is something called Taylor expansion and Maclaurin's expansion, right? That's basically to expand functions that are a little bit different to what we have here, right? Some of these functions, like for example, if I ask you to put ln x to the power of 4, then you wouldn't be able to use binomial, right? What you'll be able to use is what we're going to do now, right? You'll be able to use Taylor expansion or your Maclaurin's expansion, right? All right, so let's take a look at our Taylor first. Actually, I'll show you both of them side by side. Taylor expansion and your Maclaurin's expansion, right? All right. So in Taylor expansion, if you have to expand f of x, all you're doing, of course, you'll have to expand f of x about some value, right? Let's say you expand and it's about a, right? F of x will be equal to f of a plus x minus a by f prime means you have to differentiate. So you got to be able to differentiate good here and then substitute a plus, right? X minus a, same thing, squared. And now you have second differential by x all over 2 factorial. And you follow that pattern straight. Actually, I'm going to show you straight down the road there, right? I'm going to do one more for you. Plus, just for you to get an idea of the pattern, right? Plus x minus a all cubed by f triple prime, right? So you differentiate 3 times and then you divide by 3 factorial, so on and so on. Okay, that's your Maclaurin. So they will give you a function that you have to differentiate and then plug in the a value. All right, that's your first differential. Sorry, that is your Taylor. Maclaurin's. Anybody can tell me the difference in Maclaurin's? Anybody remember? Right, in the Maclaurin's, you're doing the same thing, except except what? If you remember, one thing you must remember from school. So when on the board, he was explaining it, and you say in Maclaurin's, you just have to let a equal to a real easy number to remember. How much homework is to do for apply for pure? None, right? Answer is 0. See how easy? See how easy? That's 0. So it will be f of x is equal to same formula as above, except a is 0. X f prime 0 plus, right, x squared f double prime 0 over 2 factorial plus x cube f triple prime 0 all over 3 factorial. That's it. Those are your expansions, and I want to show you how to use it now, right? We have a little differentiation to do. Right? Sometimes you're lucky and this comes for like 13 marks something. So those are your expansions. Of course, the question will say, well, for this function, use Maclaurin or use Taylor. Right? The only problem with this is you have to know to differentiate. So let's take something easy now. Right? Let's do a Taylor, right? Right? Write it quick. Finish. Brian, I'm waiting on you. I want to be ahead. I don't want to be lagging a half an hour behind. Because this is really easy, mouse. Once you remember to differentiate. Well, it's basic differentiate. So this could be on the formula sheet. Maclaurin's is be there. Taylor doesn't always be there. Right? So you have to remember the other way around. If they give you Maclaurin's, you have to remember. Some of the older formula sheets, according to which school you're going to, the older formula sheets have Taylor. But some of the recent ones I see they have Maclaurin's, but not Taylor. All right, so let's check out an example here. Right, let's see if we could find that's an easy one first, right? Find the first four non-zero. Find the first four non-zero terms of the Taylor expansion of f of x is equal to e to the power of 2x with a is equal to 2. So you're telling you what to use as a. A is 2, right? So let's start. First thing first, we have to find f of 2. Right? Actually, let's write it like this, right? So you get a little pattern to follow. F of x is e to the 2x. So f of 2 is e to the 2 by 2, right? Which is e to the power of 4. Right? They want the first four non-zero terms, right? So now we're going to first differential. The first differential, how is differentiate e to the 2x again? Differentiate the power and put it in front, right? So differentiate 2x and put it in front. So it's 2e to the 2x. And now you want to find f prime 2. So that'll be 2e to the 2 by 2, which is 2e to the 4. Okay? Then you're going again. That's two non-zero terms, so we have two more to do. The second differential, the differential of 2x is 2, 2 by 2 is 4, so that's 4e to the 2x. Second differential of 2, that'll be 4e to the power of 4. Same thing, right? And then triple prime, that'll be 2 by 4, that's 8e to the 2x. So triple prime 2, that will be 8e to the 4. Okay? Now that you have the first four terms, right? Now that you have the first four terms, we can write what f of x is. Remember the formula? F of a plus f prime a by x minus a. So we follow in that pattern, right? Plus x minus a squared by f double prime a and so on, right? And they continue in that pattern, right? Over 2 factorial. So f of a is what? F of a is that value, e of 4. Then you have x minus a is 2, right? So it's x minus 2. F prime a was 2e to the power of 4 plus x minus 2 squared by double prime. Double prime was 4e to the 4 all over 2 factorial plus, I'll squeeze it in here, x minus 2 cubed by 8e to the 4 all over 3 factorial plus dot, 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 dot. How much is that? Here we could do, we could just factor out e to the 4, right? So we could factor out e to the 4 and we'll get 1 plus 2 by x minus 2 plus 4 over 2 factorial is 2 by x minus 2 squared. And then 8 over 3 factorial is how much? 8 over 3, that's 8 over 6. So that's 4 over 3 by x minus 2 cubed, close brackets. Those are your first 4 non-zero terms. Right, sometimes it just be a little more complicated to differentiate, right? Right? So all you have to do all you have to do is find f of x, plug in a. First differential, plug in a. Second differential, plug in a. Third differential, plug in a. Right? And then put it into the formula. Right? Try one here, try a Maclaurin's now, right? So instead of using A is some value, use A is 0, right? Let me give you something that's not too difficult to differentiate. I'll give you a pass. We have some time. Right? I'm gonna give you one little part. Finish? Right? So let's try this one here. It's Maclaurin's, right? This is 2015. Right? G of x is equal to e to the 3x plus 1. Right? Obtain the Maclaurin's expansion up to x to the 4th. Maclaurin's, so you're using a as 0, of course. Right? Obtain the Maclaurin's expansion for terms up to, actually make it x cubed, up to x cubed. Last thing we're doing, right? So we can, Jason, you'll hold on for 2 minutes after, right? Maclaurin's expansion for terms up to x cubed. How much marks for this? That part was 6 marks. The logo, what you done? Nicholas done and sent it to me already. A shock. A shock here. Let me see when else I get something from Nicholas. Last year. Yeah, October we. Nice, Nicholas. Getting them ready here. Nice. There's a nice little easy marks here, will you? It just won the first three. We want up until XQ, right? We can squeeze in one more one. This was fast. We can squeeze in one more. Kyra, you send me something now, please. Was 27. What is that? Let's see what we got here. All right, we'll do a couple more next week and then we start estimating the roots, right? And there's it. I think I have a handout for that somewhere. I'll send it. We'll handout them. Right, g of x is that. First thing we do when we write was g of x. That's e to the 3x plus 1. Then we find g of 0. That'll be 1, right? Anything to the power of 0 is 1. Then you will write g prime x. That'll be 3 e to the 3x plus 1. G of 0 again is 3. Right? Because remember, it's 3 e to the 0, which is simply 3, right? That's okay? Deal? Talk to me now. Oh, we did just now ask about something. Yeah, 0 plus 1, yeah. So it should really be e to the 1. You didn't see that all the time, Dale? 3 e to the 1. Ah, you don't have that, yeah. Second prime, that'll be 9 e to the 3x plus 1. Plug in 0, that'll be 9 e to the 1. Triple prime. Triple prime is what? 3 by 9, that's 27 e to the. Then triple prime 0, that will be 27 e to the 1. Right? Then we go into the Maclaurin's expansion. Take a look at the formula. F of x is equal to f of 0 plus f prime 0 x plus f double prime 0 x squared on 2 factorial f triple prime 0 x cube on 3 factorial. 3 factorial. Okay. So f g of 0 is e to the 1. Then 3e to the 1 by x plus 9e to the 1 by x squared all over 2 plus triple prime is what? 27e prime by x cubed over 6. Right here, 3 factorial is 6, right? So you could factor out the e and you'll get 1 plus 3x plus 9 on 2x squared plus 27 on 6 x cubed. All right, good job, Nicholas. And anybody else got that? Ada, nice. Anybody else? Yeah, Chelsea, nice. What year said that was again? I remember. 2015. All right. It have one more part to it for 4 marks, 3 marks. Estimate G of 0.2 to 3 decimal place. To 3 decimal places. How are we doing that? Find G of 0.2 to 3 decimal places. Deal. I'll let it close off the class with that. What to do? Yeah, they want you to find G of 0.2 to 3 decimal places. Pardon me? Let 0.2 equal to X. All right. If you say so, we'll just do that. So that's 1 plus 3 by 0.2 plus 9 over 2 by 0.2 squared plus 27 on 6 by 0.2 cubed, right? During the crash course, we'll do the last 5 or 6 years, right? How much is this? Right, I'll also check. Anyway, you will have a solution. Three decimal places, huh? Yeah, how much will I get there? Just plug in the value, you know. Anybody else have value here? 4.936. 4.951. Anybody else? Right, remember you could also plug it in up here and see if your value kind of close there. So you can check E of 0.2 plus 1. So E of 1.6 should be close there. Kyra got 4.9362. You done check back yours? Yeah. How much shall I get? All right, 4.936. Okay, good. Right, and you could also come on top here and check your answer just to see if it's close to that, right? All right, nice. Good job, Shabani, right? So that's a Maclaurin's, that's a Taylor, and that's a binomial expansion, right? Okay, that kind of ends that part of the module. That's the series and sequences part. The next part is where we're going to look at estimating the root something, right? Right. There's a nice Maclaurin's that you could practice in for 10 marks in 2019 as well, right? But as I said, during crash course, we'll do all of those years. Okay. All right. So that's it. You all can log out. I'll see you all next week. Right. We have 2 more classes, right? Yeah, 2 more. Next week and the week after. Week after is common entrance, so top level. And then we have crash courses, right? Oh, Brian, you stay too. No. I want to something next week, yeah? Yeah, well, at least one of them. All right, Sarika, Jason, if you all look at your chat, I sent you all a snippet of what we're trying to do. You all got it?
Yes, sir.
All right, so what you see? Right, the write-up is the same as unit one, I mean, not